Well, hello, and welcome back. A short moment decision to do a stream tonight. I need to push forward and get my machine going, so I thought, well, why not do another stream this week? I'm not expecting people to really be online that much, and we're just going to go through some of the emotions of switching on and getting ready to go. And then maybe I'm going to do one or two wiring thing that I haven't done and before, one connection, and then I'm just going to explain one or two further connections that still need to be completed, and then hopefully we can switch on and start doing some tests. Looking forward to that. So without further ado, let's have a look where we are in terms of our wiring. I think I'm going to. I didn't have enough time. I've been out the whole day with some church event, so I haven't really been able to prep everything. So excuse me if I move a lot of stuff around tonight and try and get everybody in a way that you can see what I'm doing. But let's have a look. If we have a look at this view. Okay, so last time we connected the motors, the X and Y motor, the Z motors. We also connected the what do you call it, the beacon probe down the bottom over here. We moved the beacon probe into place, plugged that in. We plugged in a USB hub, and that goes through to the toolboard. I didn't have the connector, the actual bracket available last week, so or on the previous stream. So I just printed. Took some of the standard DIN rail clips, and I printed that, and then I just built little housings that basically sit around the end of the USB hub. What I'll do is let me see if I can bring it closer and you can just have a look. That's what it looks like. Nothing fancy, just simple, easy to mount and hold that USB in place. Now again, the reason why I'm asking for the extra USBs over here is because I intend to do a tool change at stage, so I want to put 3 extra tool heads, and so I need the 3 extra ports available. On the USBs on the Raspberry Pi, I've got the main board at the back connected over there, Octopus board. I have the USB hub connected, and then the beacon probe is connected directly into the Raspberry Pi itself. On the additional tool heads that I will bring in, I will not be adding obviously a beacon probe, because what would be the sense of having multiple probes, and we'll see if we can just use the default probing head always, instead of having multiple probing tool heads. So I can see my father's joined. Welcome. Hey, Mr. Francis is also there. Francis actually changed his name. My goodness, he's under a new identity tonight. Welcome, thank you for joining, appreciate. Yeah, as I said, I'm just going to try and get through some of the stuff that I haven't finished and try and fire up this board. I've been doing some additional prints, and I think I just want to try and get the whole printer up and running quickly as possible. I really need to start printing. I'll show you one of the prints that I did earlier yesterday for a potential client. I'm playing around with that as well. So having connected the USBs now, and as I say, everything else is connected. So what did I do additional, maybe, that while it was off camera I thought I'd just quickly put in? On my heater elements, this board has got place for 1, 2, 3, 4 heater elements. Essentially, this board you could connect directly to your tool heads, and you'll have heater element 1, 2, 3, and 4. but I'm not using that because I'm using the little tool board, the EBB board, so I don't need these connections. But that gives me an opportunity to connect also another heater, and that will be the chamber heater that I put in place. Hello, good wife. Thank you for joining. Hello, Tyron, and welcome. No, unfortunately, the wife was not first. It seems like South Africa beat you, and then a little bit down the road in Abu Dhabi beat you, or I don't know. Your comment came in third, so I can't say whether you were first or not, but I appreciate that you connected. Yeah, so as I was saying, I connected this to the internal the chamber heater. So I've got a PTC heaters that I'm going to connect. Again, let me just show you what the PTC heater looks like. It's a 220 volt, I think a 300 watt heater. I'm going to have 2 of these heaters inside the chamber heating up, and because they're AC, I need to connect them through SSR to make sure that they get the AC voltages that they need. So I've already connected up from the main controller board to the SSR wires. Pretty simple. I don't need to show you how that gets done. It's just crimping with 2 ferrules on this side and 2 lugs on that side and pushing the wires through. So I did that offline quickly. You'll see on the bottom half of here we're still waiting for a connection, and that's obviously because these need to be connected for the second half of the connection going through. The other thing that I did was the Raspberry Pi fan. So initially I was confused whether I was going to connect the Raspberry Pi fan directly to the Raspberry Pi or to the main controller board, and I asked the question very late that night after streaming on the Discord, what do people think? And I got a very simplistic answer back, and I thought, well, that was a silly question. But you know, silly questions are good because they need to be answered. You can't connect a 12 volt fan to the Raspberry Pi's GPIO output because it only has 5 volts. So the 12 volt fan would never be able to be powered from the Raspberry Pi in that sense, unless I use a step-up converter, and then I have a risk of burning out ports and things. So this fan for the Raspberry Pi is going to be connected to the controller board. Now, I've already put a wire in place for it. There is a wire that's going from the 4-pin connector. It is a PWM fan, so we can control the speed, and we can see what the speed of the fan is, get the feedback from the tachometer, and that is going into one of 3 connectors that the main board has. Let me just quickly bring back up. Oh no, I closed the pages. You know, that's as I say, I wasn't 100% ready to get into this build tonight. Let me just open up this page here and come back to supported boards and Alright, and come back. Yeah. Right, let's do that. So on the main page here, maybe I can just do a full page, and makes it a little bit easier to see. I do that. So on the bottom of here, I've got 3 possibilities to connect 4-pin fans, and those 4-pin fans, the main controller one, which is this one, the big one, will be connected over here. I have connected, screwed it in, then taken it out because it's difficult to get to the wires while it's in. I will connect it at the end once we've got the main board up and running and everything's pretty much up and running. I'll do that last connection because I'm not really going to be pushing the motors. I am no risk of overheating at this point in time. Tank Girl, now that's a privilege. Hey, how are you doing, Henriette? Thanks for joining. I really appreciate. It's good to see you online as well. Welcome to a different world. You know, if we have to compare our arts, mine's more electronics, yours is airbrush. but there's no ways I'm going to compete with you in your field. That's it. Forget it. You're very, very talented in that area. I will print the parts and you can paint them. How about that? I think that's a deal we can do. Anyway, so yeah, I'm going to be connecting this later on. So that fan is the controller fans connecting there, and then I've got two other 4-pin fans that I can use. So because my part cooling and my hot end are connected to the tool board and not to the main board, I'm actually going to use the hot end fan connection for the Raspberry Pi. Okay, fan. So you will be able to see that I have now, oh, not that one, that one. You'll see that I've actually connected that. We can bring the camera a little bit closer and you can see that as well. I've connected it down the bottom of here, and I will have to configure that at a later stage to run at the same logic as what the main fan runs, and that is as soon as the drivers for the motor drivers are powered up, what happens is the fan starts coming on the main controller. I will apply the same logic to the Raspberry Pi fan, because if the controllers are working, the Raspberry Pi should be working and should heat up. At this point, I don't think I really need much of air onto the Raspberry Pi, but rather safe than sorry. It's there, it looks good, it works, it's going to work well. Okay, what haven't I covered? What's different since the last stream? I think that's pretty much it in terms of any changes that I've thought of or worked on. The one thing that I have not done, and that's something I really want to do quickly tonight, is have a look at connecting between this power supply and this power supply. Look, on your AC side, you've got common neutral and common live going through to both, right? That's fine. Your earth is also common on both sides, so those are there. But on your DC side, on the 24 volt side over here and on the 5 volts over here, if you're working with two different controllers and you've got clocks, oscillation clocks, timer that are doing it, working off the same ground, as far as I understand, and I'll leave this for the more, can I say, electronics engineered or electronic, can I say, how do you call it, wizards to let me know, or maybe in the stream later on, or in the chats later on, why exactly. But as far as I understand, it's always better to take the ground of this one power supply and the ground of the other power supply and actually connect them so that they work off the same reference grounding. If I'm wrong in my understanding, then apologies, and then maybe someone could correct me in the comments. But I have posted in the Discord group, and I did ask the question, should I be connecting, and they said it is always better to connect the two grounds. So before we start firing up and doing things, I'm going to do that so that we can make sure that it's grounded. So I need to get some wire, and I need to get some lugs, and it doesn't have to be a very thick wire because the grounding isn't really all that, can I say, current intensive. The same wires as what I'm using to power the top would probably be sufficient. So let me have a look quickly. Excuse me while I grab a piece of wire. I'm not actually quite sure if I've got enough wire over there, and that's really too thick, although let me have a look. Will one of these wires actually fit in? Let's have a look. This is to run the grounding. I'm probably going to go from here up through to there, along there, and then up and into that like that. Let's use this piece of wood. That should be. It's a bit of an overkill, but it is what I've used for the other portions of the DC. So let's use the same wires. I wanted to show you. That's the other thing I wanted to show you with the PTC heaters. I started printing brackets, and I'll show you when I switch the head over. But I started printing the brackets. I'm trying to design a bracket that's going to go into the printer, and I'll show you when I've turned it around and we've got a camera on that side. But essentially, that heater is going to go inside there, right? And it's going to sit at the back at a bit of like a 45-degree angle, blowing hot air into the machine. So that's something I'm also working on at the moment. I've got 1 or 2 modifications to make to this little bracket, and then I should be able to print the final copies this week as well. Maybe even tomorrow if I get enough time. Let's quickly go through some stripping and some lug attachments. My set of tools are getting dangerous over here. There's too many. I need to start removing some of the tools. And let's get some lugs. We're going to use these two. Fine. So this week I've been in discussions with a local company, and I printed some. Well, they've been having challenges printing it. I'm not going to reveal the company at this point in time. I don't want to compromise any form of, confidentiality as to who I'm working with at this point. Because they haven't signed anything with me, but I can show the part that I printed for it, and that will probably give a little bit away of who they are. Just seeing this lug is a little bit too small for that wire. Why is that? That hole's the same size as that hole. That's correct. I used these previously. That's interesting. How did I get those wires into there? They're feeling a little bit smaller. Okay, let me strip off just a slight bit more. See if I can push that in properly. Thinking while I'm looking at this and thinking, how did I get that right? But it could only be with these connectors. Okay. I'm going to ask Henriette, when you coming to visit? Got lots of interesting things Michelle would like to show you, and myself. Be good to see you over here. Tara, and you as well. Come along. Buy a ticket and come visit us. And you can come help me build and print. And do a whole bunch of other things as well. Wait a minute. Nearly made a mistake there. Nearly connected that to the positive. Hey, Mr. Herman. Good to see you. Thanks for joining. Long time. Welcome to my little play area. I'm venturing out into the world of streaming and 3D printing and testing my ability to talk and work and focus and all that at the same time. Some days I get it right nicely, and sometimes I get horribly lost in my thoughts, and then I forget to talk. But I think in this, it's a live stream, so everything I do is forgiven upfront. Specifically if I forget to do something or I make mistakes. That's why we do it live, so that people can see that we're all normal and make mistakes. Had a good day at a church event today. Long hours with a big group of people, so I'm a little bit tired, but I've still got enough energy to get through all of this tonight. Okay, so that's the ground on that side. Let's get a flat screwdriver that we can open up these lugs. If I can get this cable, these tags, so I can get this cable through. Obviously still want to try and do it as neatly as possible, but it is getting very full inside, you know. Okay, let's go on the back of this one. Okay, now we're going to run all the way across the other side. Maybe switch to that side. You can see a little bit more about the machine itself, all the clips. I must say I am very impressed with these clips. I really appreciate having this system. It really is keeping the whole thing a little bit neater. I think I need to show you the print that I did, because that's very exciting. Let me grab it over here and you can have a look. So here's the first print. It is what we call a shrimp cage. Don't ask me. It's available on printables. You can get the design, but it's a very difficult design to print, simply because you've got to print without supports. You've got to get all these little linkages not to crack and not to break while it's going through. It's my first attempt at it. You probably, if you go closer, you'll see. You can't really. Maybe if I put my hand at the back there, it'll zoom in, it'll focus. You can see that those little wisps. We call that stringing, right? And that stringing, I need to see if I can focus on getting a little bit less of that in. And but to do that, I'm going to dry my filament out a little bit more, and I'm probably going to change my Z-hop settings a little bit, my retraction, just play around with it. So I did that one, double size, and then I thought, well, let's print one on the actual size that the drawing is. And that's the baby that goes as part of this whole set. This is super difficult to print, simply because it is so small. Those little linkages are so small and they break so easily. But this is done in ASA, right, in a 60 degrees heated chamber. And it's come out very well for my first attempt. Yes, there's a couple of things I've seen now. I'm going to change a couple of settings and I'm going to actually try and print this again. But yeah, there you go. Possible. Not even on the big printer yet. Can you imagine I can print that one at about a 400 by 400 by 400 size? It'll be quite amazing. Let me put this back. Yeah, that was done on the two other printers that I have. I think, France, you got to see the start of those prints. It really was interesting watching it. I actually made it a small time lapse of it, just to watch it. It's quite phenomenal to watch that thing grow. Unfortunately, it takes like, the big one took about 7 hours to print, which is quite a bit of time. On the small one, because of the type of printer, and also the size being so much smaller, it only took 1.5 hours to print. But then it's got far less plastic in it, so sort of can understand why it takes so much less. Get these sorted, so we'll lay down over there. Push these in there. Also going to be printing, otter skull. A sea otter skull is what I'm going to be printing tomorrow, most likely. See if I can get that right. See how that goes. I'm sure I'm going to get it right with the systems that I have. And these are still on my old printers. These are not on my new printers yet. On the new printer, because obviously you're looking at the new printer. It's still a work in progress. Let me just push that wire through like that. I think I've got it reasonably neat. Okay, starting to become quite a large amount of wires running through this poor little machine. Like that one in there. Okay. And on this side, to cut that over there. Give or take over there, should be fine. The side cutters, I think it's had its days. I can see it's really not doing well. Goodness, look at all the people joining. Maret, welcome. Thank you for joining. Appreciate. Andre, welcome. Brother-in-law online. That's really nice to see. Thanks. I appreciate, Andrea. It's something I enjoy doing. I enjoy the machine itself. I still need to try to decide whether I enjoy the live streaming. Maybe I'll continue with it in the future. Maybe not. But what I definitely will be continue doing is doing these 3D prints. I'm just trying to get to this one. Sorry if I'm a little bit out of the screen, because it's just easier to stand and do it. Maret, how's the new car doing? All good? We haven't seen each other since you've got your new car. I can see my wife is very busy on this side. Thank you, I appreciate. Make sure I connect it to the right thing. It's one thing doing this while everybody's here and trying to watch the stream and make sure that I'm commenting and saying hi to everybody. It's another thing not to plug and connect everything in the wrong places, you know. It's only 220 volt or a nice DC voltage if you get it wrong, you know. It's nothing serious. Everybody's waiting for that moment, they say. When every printer build I've watched, the guys like stand back and they push their power button. They stand back and say, right, they're waiting for what they define as a pixie smoke, right? For the pixies to be released. Well, we don't have to worry about that. I'm not going to worry about pixie smoke coming out of my machine. I'm confident that what I've been doing is working well, and that's why when we built this machine, we did it step for step. You know, we did the AC first. We made sure that the AC was correct. Then we checked the DC. We set our DCs, and then we move slowly to the next step. The thing is, we should always check it, because once we start connecting motors and the rest of the devices, it becomes expensive to have a mistake. So no, that's why I just did it slightly different. Hopefully whoever watches this video in the future can appreciate that, you know what, don't take a chance. Do it step for step and test as you go. It's a bad thing to write it there and just stand there and switch on and hope nothing blows up. Okay, so I think I've got my power connected, my ground wire connected between the two boards, going from the ground there. Let's have a look to the ground there. So in theory I should satisfy all the electronics guys out there, hopefully. Someone else can tell me why, in a more technical reason later on in the comments maybe, why that's needed. But I do believe it's got something to do with the oscillation on the frequency on the clocks on the DC side of the main boards. A little bit technical for those that don't know, but don't worry about it. They recommend it. So there we are. I'm not going to put this fan in place yet. You're going to have to imagine it there for a little while. We can swing around to the other side of the printer and have a look just from this side for a moment. Maybe even let's go as far as having a look here. I've got my board. Remember, my board is connected, and I have my connector connected so that my board is up and running, all good to go. Just as a matter of interest, I decided to check the panel, the black panel that's going to go into the bottom of this printer, just to see that it actually fits. But I'll put it back so that you can just see how it looks. It's going to change quite a bit of the look already, just putting this bottom panel in place. I think it looks super cool with the black panel in it, right? I need to drill the holes on this, just cut out the holes, because I remember I used window tinting on this. So I need to just cut these holes out. They are drilled on the piece, on the polycarbonate. They're just not on the actual tinting that I put in place. Put those through, drill some holes through, put the brackets, and I'll tie this down. I'll do that off screen. I'm not going to bore you with showing you that tonight as well. We'll just move along. What is there? Oh, let's have a quick look at what the PTC heater is going to look like in place. Let me just grab this PTC heater. Right. Let's grab this one. I think I've shaped the wires a little bit. So this heater is going to be sitting over here. Almost looks like speakers. It's not speakers. It's heated music that comes out of here. Quite hot. A 300 watt heater on there. That's going to sit over there, and I just need to drill holes through to the back to have these heaters connected. And the other one will be sitting on this corner, and they'll be blowing up air into the chamber, not directly onto the board itself, onto the heated bed, but just along the sides and pointing slightly up so that I could sort of get like a cyclic action to heat up the air. Obviously hot air rises, so as the bottom chamber here starts turning with the air warming up, it will heat up and the hot air will rise, and then when it gets to the top it'll just become stagnant, and then the machine will switch the heaters off automatically and then control the heater there, the temperature. Okay, so yeah, what next? I think what we're going to do is, just for safety's sake, I recommend that we actually bring the bed down a little bit before we switch on. So maybe if I just switch over to this view, I'm just going to turn the motors at the bottom and see the bed dropping. Again, I need to get it sort of equal, so I'm going to have to do the back as well. Because when you switch on and you're home for the first time, the bed is supposed to move slightly, but if it moves in the wrong direction, you could possibly land up having it go straight into the printer head. We don't want that, so let's just move this slightly down. And we don't have to worry about being level, we just sort of like got to gauge that it's roughly the same height. So let me grab, I'm just going to grab this vernier over here and just check that I've got it roughly the right height, the same height around between that. It's about 105. About 105. Let's just check the back one. Yep. And the only reason why I'm checking if it's roughly level is if it's too high on the one side, you can run the risk that when it raises, it actually pushes. If this corner was too high, it would come up and it would actually break this bracket on the side here. So just get it to roughly the right height. We're going to do a bed leveling with the software in any case. Okay. Swinging around this way again and switching to this camera. Power going in. Remember, I've got two switches, one that switches on the Raspberry Pi and one that switches on the main controller board. So I'm going to switch on the Raspberry Pi first. Just make sure nothing strange happens. At the bottom of the Raspberry Pi, you won't be able to see it, but there's two little lights there. You can probably see my fingers, got a little bit of a glow on it. Yeah, that means the Raspberry Pi is starting up. If we go to, yeah, okay. Hey Julia, welcome back. Thanks for coming back. I know you probably received your printer by now. Don't know if you've unpacked it and had a look at it, but I'm sure you're getting just as excited to start building it. So look forward to seeing some of your updates as well. I don't know if you're going to stream or you're just going to build in the background, but maybe we can connect on a private message at some stage and you can show me some pictures on your side. Yeah, well, I see my father commented someone switches on with a broomstick. Well, I watched a guy in Canada. I think if he could climb under the table and push the button and switch it on, he would have. That's how scared he was. Yeah. Pro V. What else I can? Who's Pro V? I'm trying to figure that out. Yeah, no, I'm not sure who Pro V is, but welcome. Obviously, you know my father, so might be a cousin of mine. I'm not quite sure. Yes. Anyway, so let's have a look. Do we have connections? Yes, Raspberry Pi is there, and what do we expect? Well, there's an error because we haven't switched on the main board. So let's switch on the main board. No more. You'll see. Don't have to do broomsticks and stuff. Not worried about that. We did our work diligently all the way up to this point. Obviously, we also in the previous streams we did the firmware update and did the installed what we needed to do. So yeah. everything should be okay. It's just the additional components that we've added, and that's why I'm not really worried to switch on at this point in time. Let's have a think about where we are now. We've got to push firmware restart because the board should be there. And let's see what error we get. Alright, so I think last time we had some error like this as well. Option pin select must be specified, and I think it's because we were still connecting a whole lot of things up. So I'm going to go quickly back into the printer config over here and have a look at what's going on. I'm going to run through it one more time just to make sure. Yes, we have the Max EZ board. We've definitely selected that. These are base setups, they're normally there. Yeah, we have included the 2209 LDO drivers because these are the standard that most boards use, the 2209 drivers. And when using the uncooled one, meaning I haven't got a cooler on here, right? If I do put the cooler on and I want to increase the speeds and stuff, then I'm going to come out and comment these out and uncomment these, and then apparently I'm going to have more performance. Let's see. Do I need more performance? I'm not worried about speed so much. I'm not a speed freak when it comes to. I'm more about a quality of my printout. So we'll see how that goes. Then on the stealth mode, we are able to actually decrease the speed even further and make sure that we don't have so much noise, and then we can also put the machine into stealth chop mode. I'm not going to do those. I don't need to be quieter or less accurate. I'm looking at being as accurate as possible, but within the normal speeds. Yes, we have the 500 printer, the 500mm printer, so that's quite good to see that it's all still there, nothing's changed. We haven't included our end stops really because oh wait, here we go. We need to include the beacon because the beacon is now included, and I think just having a look at the comment here, we need to do the beacon calibrate, so we'll probably do that as soon as we've got the machine in a stable mode. We're not using the end stops, we're not using clicky. We are using the sensorless homing. Remember, if you've never done a printer like this before, build the end stops in, put them in place, because if you don't know how sensorless homing works, you could damage your machine and the motors. I've got it on my small Vora printer over here, successful, so I'm pretty confident that I'm going to be able to configure it and manage it as we go along. We'll switch it on. I understand that the default settings that are in are pretty good already, so it should just work. Where we are, input shaper, we're not going to use the input shaper connected to the main board because we've got it on the tool head, on the tool board actually. What I'm saying, on the tool head we're using the orbiter, yes. We're using the Revo, yes. On the fans, right. So yeah, I'm going to use the 4-pin fan. I think the difference between 25 Hertz and 100 Hertz, I stand to be corrected. I couldn't see anything about this. I read it a little bit in the week. I think it's more around the speed of the motor. I'm just going to go with the 25 Hertz. Hopefully at some stage someone can put a comment in if I'm wrong. I will also reach out on Discord and just ask what is the difference there. How do I know what's the difference? But it seems to be something to do with the speed at which it informs the fan as to what speed it should be running. Okay, these are all standard macros. We're not going to touch these. Yes, you can configure and change these macros later on, but we're just going to go with the standard stuff that's there. The stepper motors, fine. They're all in the direction that we expect. or put it this way, they're in default settings for now. We'll see how it goes. And here's that probe that it was moaning about. So we're not using the inductive probe. We're not using any of the BR. So we're just going to comment out the probe and comment out the Z offset. I think that's what I did wrong last time. We don't need that. These are the pressure advanced settings. 0.5 on the extruder. We have the nozzle, that's fine. We will need to check whether the filament pushes in the right direction. We'll have a look at that a little bit later. And the heater bed PID is fine. The resonance, the probe points, so resonance probe points is pretty much half of the bed, 250 by 250 by, and then 20. I'm trying to think, what is the 20? I think that's half of the bed and half of the bed front. Anyways, I'm going to leave these defaults. I'm not going to worry about them too much. Yes, we are using the EBB tool headboard. We are using, okay, you need to uncomment that, correct. That just has to be there if you're using any form of tool board. We're not using a BL touch. We're not using any form of probe. We can change the direction of the extruder at this point. We don't need to do it there. I must just check whether that makes sense, having the direction over there. Oh, hold on, that's direction pin. That won't control the extruder. That's interesting. Yeah, we might have a problem because I would expect this extruder settings to be actually in this section over here. When we get to the actual extruder and printing both directions, we'll have a look at what it does. To change it, I think it's going to have to be that one over there. We're not using XN stoppers, we're using sensorless homing, and the ADXL, yes, we are using that. So I think that's fine. I'm just going to remove this now because I was playing with something in the week over there, and I'm going to save and exit. Let's see if this machine will start up. Attempting to connect. There's something wrong on the direction, the Z2 direction pin. Did I mess up something over there? Totally possible. I was playing with, yeah, I did. I was playing with this in the week, trying to change one setting. I was trying to find the probe error, looking totally the wrong area of place. And there you have it, up and running, working. Go to the main dashboard, and we have a printer that seems functional and happy to go. We can see our extruder temperature. We can see our heater bed temperature. We can see the beacon coil. Oh, I didn't know we were going to be able to see that. That's interesting. You can see the beacon's heat temperature. That's the actual Octopus board. That's the Raspberry Pi, and that's the tool head. Oh, very nice. They've really done the layout very well over here. It's cool. I like that design. Obviously, this looks a little bit different to the standard clipper main cell interface. Let me do this quickly. Let's go to just a Voron over here. You'll see this is what it normally looks like with the color scheme, right? They've obviously, because they are RatRig green, they got to RatRig green everything. So they've probably built themes for it, which is quite nice. Just getting back to the machine, I think, as I always say, it's very important to keep your machine up to date. So before we really go into any further configuration, I'm rather going to do a quick update. I know I did it last time, but there are updates available. Let's just let it double check one more time before we push the update button. What's the time? Not bad, 1 hour, and we're almost ready to start moving the head. I think there's a expo on one of the maker fairs in the USA at the moment. Man, I'd love to go and attend one of these maker fairs where all these guys with all the brands, all the big names, and Bamboo Lab and RatRig and Prusa and all of them there. Okay, seems like it did add one while I was down there, so let's just do update all, and I'm going to click on I understand, and I'm going to say start the update. And there we go, update running, and hopefully that doesn't take too long. That goes through pretty quickly. And then once that's done, we're going to swing the machine around and we're going to start looking at the printer head movement and see what it does. The reason why I'll do this update is sometimes from time to time Clipper, the Clipper team or RatOS or Mainsail will depreciate certain functionality, and that means that it's been removed and it's been replaced with something. And so you don't really want to get to the point where you start doing all your setup and all your checks and stuff, and then you push the update button and well, now you've got to go back to the config and try and figure it out again. I'd rather figure that out now and make sure that everything's running. It doesn't happen all the time, and they do pre-warn you. There is a place where it'll come up and say the following stuff will be depreciated in the next few releases. You need to start taking note of this. You'll see over there something that RatOS have done very well and successfully is to actually flash the connected MCUs. If I was going to go to this printer and do updates over here, right, this standard configuration does not actually, when it updates Clipper, it doesn't flash the boards, which is quite painful because then I have to go and do it manually. Over here it actually flashes the boards automatically as part of update, and that's another reason why I will move probably most likely this little Voron onto the RatOS setup as well, just to make my life a little bit easier. There we go. Let's try again, see how far it is. It's busy restarting. And if we scroll down, full update complete, that's it. Done. Close. Initializing. It's all updated. No errors. We're still up and running. I'm going to run this one more. Can't even run it. Can't even do another check. Good. We're there. So coming back here. All looks like it's still working fine. Good. Fine. So let's swing this machine around, and without pulling out the power cable, let's see if that will work. Can I get this machine to turn? Yes. And I'm going to come over here. There you go. That camera feels a little bit skew, but that's fine. It's not that end. Well, that's better. In any case, it's not straight, but you don't have to worry. The printer is straight. Okay, so first thing we're going to do, let's switch to this view. I'm actually thinking you can watch from that angle as well. Watch from that angle, that angle. Yeah, because I'm going to be using those buttons. Let me move the screen just over a little way. Just easier to see. And we are going to start looking at the actual homing. Now, what you can do is a buzz on your motors, and let me see, is it free? It's moving. It's moving freely, so I'm just going to bring it to the middle over here so that it doesn't move around. Let me just anchor this machine a little bit. Push that rubber in there. Push that rubber in there, otherwise it keeps turning. Right. So what buzz is going to do is you're going to see just a slight movement of the motor, and it should probably, from your view, move the motor to the right. I think you'll see it will just move slightly. You can hardly see that. I can see it on my side. It is moving, right? So nothing wrong there. We do have movement on that, and we also I'm just going to do a stepper wire buzz just to make sure that I don't get any errors. Yeah. Okay. You probably, I don't know if you can see the movement. It's very slight. It's just so that you can see if your motors are moving, and they're moving sort of like in the right direction. I don't know how well it works on Core XY, but it's definitely moving in all the directions. So what do we need to do? I'm going to bring the power switch close to me. Right, I'm going to just put it on the table here, because if I move the motor in the wrong direction, then it looks like it's going to crash, or something's going to go wrong, or it starts churning the belts. I want to be able to hit the power. Now, probably not the best thing to hit the Raspberry Pi. I should be hitting the red power switch, but because it's so far away, I'll just kill it all. Let's see what happens when we move X. So if I'm going to move X, it should move over to the side and hit this side and stop and come back. Because it's got sensorless homing, it feels the resistance in the motor, picks up that, and then says, okay, I've reached the end. So let's see what it does. Oh, that's good news. Awesome. That worked well. I'm not very comfortable with the fact that the bed went up. I think the bed should have rather gone down, because that could have crashed into the head. Okay, we still got, it only moved a little bit. It only moves a little bit, so let's just do Y and see what Y does. Okay, it's moving. It's definitely, it's homing to the wrong side, so I think something is not right. Okay, we can't home Z yet because we haven't set up your Z offset yet. That would damage if it just went all the way. Let me just move the printer head to the right. Okay, can you see when I'm moving to the right? You've got to now imagine it should have moved to the right on your camera view as well. Because X is increasing, right? And this is the higher side of the board. This is 500. So it's definitely moving in the wrong direction. Let's see if moving this to the back of the board. So if I increase Y, it should move backwards. Okay, so obviously something's totally the opposite direction. It is moving, which is nice to hear, but it's definitely moving in the wrong directions. So let's quickly go into the machine config printer here, and that is this section over here. All right. So first of all, I said Z was going up instead of down, which I would have preferred. So I'm going to remove these exclamations, which changes the direction of the machines. The three motors, obviously these three motors have to turn in the same direction. There's three motors controlling. You can't have one going one direction, the other. So you're going to remove it all three. And normally you would want to move your X and Y in the opposite directions, both. Whatever you do to the one, you have to do to the other. So let's see if that makes a difference. Save and restart. Should see the board come up. Right. Back at the same place. Let's just do X on its own. And I want it to move to the left. Ah, that's much better. Much better. You saw the board, the bed moved down, which is the right thing because it needs to give space just in case if the bed is too close to the head. It needs to move away so that X can move. And then the same with Y. Y should now come to the front and move. This will move down, or Y should come to the front. Well, there you have it. That looks brilliant. Really, really happy with that. Good. Now the next thing is we need to get Z working. We need to get Z tuned in because it needs to know where the top of the bed is and where the bottom is. This is where we could probably go and have a look at the beacon software. And I was having a look at that earlier this week. Do I still have the beacon? Did I have the beacon software open here somewhere? No, not. Beacon probe. So let's close that one and let's just go to the beacon probe. Now, if we go into their website and we go look at docs, right, we go to the quick start. So yeah, they talk about the mounting of this beacon probe. You can go and have a look at this because not everybody's going to put a beacon probe in. I am doing that. Routing the cable, they give you a bit of installation guide there, and then they talk about the whole install guide. Now, if I didn't have RatOS, and previously to the recent releases of RatOS, Beacon wasn't there, then I would have to come in and do these installations manually, because RatOS knows beacon needs to be there, and you sort in the configuration. They've done all this installation and pre-configuration for me. I can see I'm going to be any moment pounced on by a cat looking for love. When you finish configuring this, what we need to do is make sure we have a bed mesh, and that's already done, taken care by RatOS themselves. Then we need to calibrate the beacon, right? And what they say is, here we go. Good day. You come to join? Yes. He's now going to want love, but it's going to become a problem. So we'll give him a bit of love and then we'll push him along. So you would normally home the machine for X and Y first, because you can't home Z yet. We'll position the nozzle. So I'm just going to position it roughly in the middle. And then we're going to do a beacon calibrate, right? So let's take this beacon calibrate, and that was the same instruction that was given in the config file. So if we go back to the machine and we go to printer here, inside this configuration, where did they do it? Did I miss it now? Yeah, I must have missed it. Oh, there it is. They say just include it. They say everything is installed, just connect it and run the beacon calibrate. Right? So we're going to run beacon calibrate. Let's close here. Go here. And we're going to do that. And when we run this, we should have a screen that pops up. Now you can see it assumes the bed's at like pretty much the highest, well, the furthest away from the actual head, and so we're going to have to now move it closer and closer and closer until we get that nozzle at the right distance. Simple paper test. So what I'm going to do is I'm going to put a camera in a different place now so that you can see what I'm doing. Hopefully I don't drop the camera. Let's see if this will work. Okay, Mr. Cat, you're going to have to move along. Thank you for the visit. He's not going to accept that. He'll be back. Let's see if we have the side camera and okay. So that's what the top, but that doesn't help you because you're not going to be able to see the screen. So if I do this, maybe I can change this camera. Let's just see this table camera. Let's switch that one off for now, and let's add one more camera to this view so that you can see the top over there. Video capture device, an existing one, and side, I think it's called side cam. Right, there we go. Now we can just bring that like that. Great. You should be able to see the top now. Give you a good set of views there, and I can push these buttons and you can see. Right, so let's go. So what we're going to do is we're going to put a piece of paper up the top here, and we're going to do a simple test to see if the printer is touching the nozzle or not. Maybe I can just bring that slightly in, right, so that you can see that one down there. I'm now going to use this -1 because I want to bring the bed up. Bed is moving up, that's good. Minus means bring the nozzle closer to the bed. Unfortunately, I'm going to be pushing this probably about 100 times. I don't know how to do this faster. Okay, we'll just go with it. We are getting closer. How much closer are we? Still a little way. Unfortunately, the printer is much taller than what I'm sitting, so I need to lift my head slightly. Alright, now it's getting close. So I'm not even put my eyes on it, I'm just going to watch the cameras on the screen. I can still move that paper easily. And I'm just clicking -1 at a time. Right, the other paper's got stuck. So it's really stuck, it's gone down too much, so I'm going to go up by 1 again. And then I can move. Go down by 1. Yep, too much, okay. So now we go to the next level and we say, go down by 0.1. Can I move the paper? Yes. Can I move? Yes. Can I move? Yeah. Yes. 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 Oh, okay. There it gets stuck. Now, it feels a little bit too tight, so I'm going to go up by +, yeah. It's very loose. Now I'm going to go to the next setting. Down 1. I'm not quite sure. Let's go up there. Let's go down even to a small increment. No. Barely touching. A little bit more. Okay, that's pretty much where I want it. There's enough resistance on the paper. I'd rather have it a little bit higher, and then when we do the first prints I can lower it down. Maybe I'm going to go down 1 more. Yeah, that's it. No, we're going to go up 1 more. I feel more comfortable there. And if we're too close with the first layer, we'll see it. If we need to come down the first layer, we'll adjust that at the time of printing. This is just to get us at the right level. Now we can say accept. Right, accept this. The beacon is now doing some calibration. Right, it's done some calibration, and now what's important is that we push save config, because otherwise whatever we've done was a waste of time. Save config, and it's now going to save that configuration into the main file. Right, at this point I can move away this plug because I no longer need this. I am now comfortable that the machine is ready to go. So let's do a X homing. Bed goes down. Head's going to move across. Okay. Then let's do a Y. Head will move forward. Okay. There's a little bit of a bump there. I might just change the configuration. As I said, our local mascot over here will not accept 1 rub. He needs at least 2 or 3. And he'll lie down, and hopefully if he just lies down quietly, it's fine for now. The next thing is we're going to do a Z check. So this should move the bed and do a Z probe, and with that we will have actually for the first time a head that's ready to move, and a head that can move around freely from there onwards, because it'll know exactly where the bed is. Let's do a Z. Goes up. Right, we have X, Y, and Z now set up. Right. What I want to double check again is if I increase X, it should move to the right, which it's doing. If I increase Y, it should move towards the back, doing that. And if I increase Z, the bed should move down, meaning it increases the space between the nozzle and the bed. And it's doing that. Awesome. So all our basic directions are now configured, and we have a calibrated beacon, so our probe is ready. So we can now do a tilt. What is the tilt going to do? It's going to take 3 measurements on the printer, and then it's going to adjust the bed, trying to get the bed level by itself. So let's see what that does. Take one front left. Take a measurement at the back. Right, now it should do a calculation. And it's sort of, I could hear it adjusting the bed, trying to get a level. I might do another one in a couple of minutes just to show you what it actually does. I'll make the movement a little bit more dramatic. Let's see what it does. Let's first finish this. Okay. What I can see is that this is getting worse and worse and worse, right? The tilt is getting worse in the bed, and I don't want it to go too much further, because the next time it goes, it's probably going to crash against the frame. It's going to push it even further away. Okay, I'm switching off the main controller, and the reason I'm switching off the main controller, you can see this corner was dropping more and more and more, and that's just a telltale sign that it's trying to fix the height of this corner, and instead of moving this corner, it's moving this corner, right? So it's compensating on the wrong motor, because the motors are connected most likely the wrong way around. Okay, because the direction is correct, but it's compensating on the wrong motors. So let's take a minute to see if we can fix that. I'm going to switch to just this camera for a moment. As you can see, our cat has decided to join the printer. Let's see if he enjoys having a little bit of a rodeo on the printer. Mr. Cat, here we go. I don't know what you think about this. Just move this power cable in the right place. Alright, cable's in the right place. And goodbye, Mr. Cat. I think he enjoys that. So let's just bring this camera slightly closer that you can see what I'm going to be doing. So remember when we connected, that was the center motor and these were the two back motors. Got a feeling that these two are the wrong way around. So I'm just going to open up this. Make sure your board is off before you pull cables. My board is off. You can see there's no little lights flickering down the bottom here. Okay, I'm going to take that one out. That one. And I'm going to pull that one over there. Plug it in there, and that's why we always left a bit of extra cable and a bit of play here and there just in case. Right. Put those two in. That I need to make sure it's out of the way for the. I've got to bend these wires in because this fan leg is going to come in here. In actual fact, it should be fine there. Right. That one's like that. So now I've swapped those two around, and hopefully that'll work. Okay, let's our manual zoom out, and we now are going to I'm switching on the controller again, And you'll see the lights are going to come on. In the meantime, on the software, you'll see that it lost connection to the board. We give it a couple of seconds. That's my father-in-law. Thank you for joining. I appreciate you coming in. And yeah, it's not that difficult, but if you haven't worked with these machines before, yes, it can be a little bit lost. That's why some people just buy printers that work, and some people like me like to build printers. We get tinkerers, and we get people that just want it to work out of the box. So this is not a printer for the person that wants it just out of the box. But I love what I do. Right. So I'm just going to click on firmware restart. It re-establishes a connection with the main board, and we're back. So let's swing around and see if we can get this. Please note that the printer won't be on the stand going forward. This is just on the main stand while I'm busy with my tests, and once we're finished, I'll move it into a standing position. But you do not want to print on a rotating bed like this. It will not be good for the printer. And also you don't want a cat inside, but don't worry about that, he won't be there when we do the print. Okay, let's just quickly, I just need to quickly shift this one camera and put it up the top. Okay, so we can see there's quite a bit of tilt in this. I'm still comfortable that it's reasonably okay over there. It's one thing I don't like about the cat. Yeah, his fur sticks to the rods. I'll have to clean those rods at some stage. I can't totally remove cat at this point in time. Okay, so let's home the printer again, because we need to do a home before we can do a Z-tilt. If you try and do a Z-tilt, it'll just say to you, you can see on this side over here, all the axes need to be first homed, right? So let's home this printer. Right, now let's do the Z-tilt again and see if it's any better. Hopefully, because otherwise I'm going to crack this bracket on the side here. Let's see. But I'm pretty confident on it. See? Doesn't like that. There you can see it try to level up at once. It's going to try again. There, did a slight adjustment. I could hear it, you couldn't see it. Actually, this camera should be tilted slightly because it looks like we're not level, but I promise you we are. There we go. Alright, so what you can't see on the right side of here is, let's take this video and just move it out of the way a little bit, that side. There we are. On this side, you will see that it tried twice. It got to a 0.009 range difference, and the tolerance that's currently set is at 0.02 of a millimeter, right? So that's highly accurate. It's happy that that bed is pretty much level. So that's good news. We have a level bed. We have things moving in the right direction. What next? I don't know. Probably we need to put some plastic in it. I think there's one thing I wanted to do on the beacon probe, just for interest's sake. There is a probe accuracy measurement, which I wanted to do. I just wanted to show you how accurate this beacon probe can be. So let's go to RatOS, and then we're going to paste the probe in there. That's going to push the probe down, and it's going to take quite a few readings. So have a look on this side. Let's go to the console, where you can probably see a little bit more how quickly it's going to run. And we'll paste it there. So when I hit that, it's actually going to go to a position, then it's going to do quite a few readings, and then it's going to tell you the accuracy of the probe. So it took what, 2, 4, 6, 8, it took 10 readings, and of those 10 readings, remember it's using magnetic field to read the height. The maximum measurement it got was 2.002768. The minimum it got was 2035. That's a range difference of about 0.000732 of a millimeter. And can you understand the actual accuracy over there? And the deviation is just like so little. You can't see that. We printed when I use a 0.4 nozzle, I'm printing at 0.2 of a millimeter height. So that's really accurate. Okay, what we can do is we can do a cold bed mesh, right? I think that's something we should do, and see how this thing's now going to read and build a map of the bed, a heat map, or height map. I call it a heat map, but it's a height map. Right, so let's calibrate. I'm just going to use the default of here. Normally I would say what temperature I'm going to be calibrating at, but because I haven't got really a temperature there, I'm just going to leave it at default, and yeah, let's try to see what happens. Move is out of range. Why is that? Let's go back to the console. Move out of range 20 -720. Okay, I need to probably go and set up my bed measurements and everything, and that I'm not going to do on the camera because every print is going to be slightly different. I think it's something that we need to try and measure out and just set that we're reading in the right places. It's obviously trying to go to a point which is not within the confines of the printer head. So let's just go back. I just want to do another homing here. Just want to double check that it does the same thing again. I would have actually suspected that it actually does the height map, but alright, definitely I need to go and work on the height map. So I'll have to go and set up that a little bit and play around with it a little bit. I'm not going to do that now because it will just take some time to figure out the actual measurements and the coordinates. Maybe what I'll do is in the next video I'll just show you how I did it, and then you know how to do that for the future. I think what we can do, however, is we can load some filament and see if the filament will actually push through the extruder. So let's just bring the head away from the actual printer head, and let me grab because I haven't got a spool holder connected up yet. I think what I'm going to do is use one of my filament dryers as a spool holder. I'll just put it down inside the printer for now. Let's just do that. No, sorry, that one. So I've got these filament dryers I showed you previously, and inside that I can put a roll of filament. And what filament are we going to throw in there? I want to do something simple like a PLA. Let's use this PLA that's on this other printer for now. Take that off. There's not much filament left on the spool, but we only need a couple of millimeters of filament in there to actually give us the ability to run through the printer. So let's do that. Okay, and for now, very rudiment, but we're going to keep this very long tube on, and we're just going to push this filament through. Probably going to take a little while to get the filament all the way through. Be also a good test to feel what it feels like going through and how tight it is, because it is definitely quite tight. And that could be another challenge, that this tube is too tight for this filament. It is very tight. I would have expected that to move through there carefully. I don't like what I'm feeling. That is disappointing. Let me just cut this filament one more time. I just want to double check. Worst comes to worst, we'll just push the filament directly through for now. And then I can check this tubing later. Okay, this is very tight. I'm not going to work with this for now. I need to check if that tube is faulty or is it what's going on. So for now, we're just going to go with a very simple process of lifting that out there, and I'm just going to load the filament directly into the extruder itself. Maybe what I'll do is just grab a short piece of filament, of PTF tube, as we just want to do a test. So let me just point this camera up slightly. Okay, just gonna put a short piece of this tube in here. Right, and then push this through. Okay, I can feel it's got to the motor. So I think the next thing we can do is we need to heat up the extruder and we need to heat up the bed. Yeah, I'll have to do that for 1 and 3 for the cable labels that I've got in the back there. You're right, I need to change those labels. So let's just heat up the bed. For safety's sake, let's remove the cat. Not that he's going to be very happy with that. Let me put him on his perch up the top here. Hopefully he'll stay. He's got a little shelf in the background that he loves. So let's just increase the temperature of the main bed. And see that we actually get it up to about 50. You can see on the scale over here that it's changing and the temperature's going up. Move that to the side again. It's a big bed. Takes a little while to heat it up. Okay. So at least the bed is heating up to 50 degrees. It's reached the temperature and it is able to hold that temperature. Right, let's push it up to my standard printing temperature. Let's see how it goes. We might get it out of range if it takes too long because I haven't done a PID tuning on this. PID tuning will actually do a test to see how long it takes to get from one temperature to the next, and if it takes too long it will actually stop it, as it, for safety's sake, it feels that it's taking too long to heat up. But I think they inserted PID values that are roughly correct. Obviously we need to run a PID tune again. We are able to get to the temperature, it seems. Let's see, are there macros down the bottom? No, there's no macros down the bottom here. I was just having to see if there was a macro that I could run for a PID tune. I would have thought they would have. Okay, so it's there. It is definitely getting that temperature. We're good. What I'd like to do is touch this little connector at the bottom here. I'm just feeling the bottom connector. Just to make sure that connector doesn't heat up, and it's not hot. It's the connector is nice and cool, so it's not overdoing it in terms of current. Okay, we got that done. So I'm now going to switch that off, cool it off. Let's now get the extruder temperature for the, let's get the nozzle up up to 50. Let's see what that does. The fan did come on. I don't know if you can hear the fan. I can. This fan came on, which should be, just touched my arm on the heated bed, silly. That fan came on, which is normal for when the extruder is running. Okay, reach that temperature. Let's just go a little bit further. No issues there. You might see on the Revo that there's a blue nozzle on it. I'm going to start off with instead of a 0.4 nozzle, I'm getting a 0.4 nozzle size. I'm going to start off with a 0.6 nozzle, slightly bigger. I'm planning to use that mostly on the bigger bed, on the bigger prints in any case. Alright, that's reached temperature. What I'm now going to do is I'm going to hit it up to 210. Let's go all the way. I don't see any issues at this point. We're getting there. Yep. Right, so we've hit that temperature. So in theory, I should be able to push plastic through the nozzle now. So let's go to the extruder. Let's just do it slowly at first. And let's ask for 50 mils to be pushed through. I'm going to put my hand on the nozzle here so that I can feel it. Let's see if I switch to this view. Yeah, you can't really see me. Okay, but I'm going to be pushing the plastic in any case on the back here. Go back to that there, and then just maybe zoom out slightly. You don't have to see my ear, but I'm going to zoom out to there, and I'm just going to take the plastic over here and push it in while I'm pushing extrude. So let's see, does it grip it? I can feel it's pulling it in. Yep, it grabbed the plastic, and at some point we're going to see some filament come out the bottom end there. Let's zoom in a little bit more. I think it's finished with 50 mils. 50 mils wouldn't have got it all the way through. Let's push another. Let's see, I can probably shrink that and shrink that, and I can extrude. You can see it's busy, and we should see plastic come out there any moment now. Not. It's a big nozzle. Let's try some more. Definitely pulling it in. There we are. There's some of the plastic coming out. Great stuff. We have launched. So, we could possibly load just a cube or something to print, but I'm not going to do that now because I first want to set up a slicer and connect the slicer, set up the slicer for this, and that's what we're going to do in the next stream. So in the next stream I'm going to connect the last of the fans at the back. I'm going to set up a little bit of a do a bit of configuration just to get both of the Raspberry Pi fan working as well. And once I've got that up and running, I'm going to start closing the casing. Oh, we're going to put the PTC heaters in. I still have LED lights that I want to put on, but I'll do that maybe on the sideline and then just show you later what I've done. And I've also got a display. I've got the clipper screen that I still need to print a housing for and do that, but that's not important now. I'm going to get the printer up and running. I can do the clipper screen at a later stage. That's not don't need it. That's just a nice to have on the printer itself. So let's take the temperature and switch it off. Let it cool down, and that's it, guys. I think we've reached a good milestone. There's plastic coming out. We're not going to print anything now because I need to first, as I say, set up the slicer. We are going to use Super Slicer. Let's put it this way. I use Orca Slicer, right? Now, because the RatRig team have got profiles for Super Slicer, initially I will do the demo of that with the Super Slicer, and I will then on the sideline move over to Orca once I'm comfortable that the machine is working well. Super Slicer is very easy to get. You can just go Super Slicer. It sits in the GitHub repository. You go, yeah, this is the latest edition. Move to the latest edition, 2.4. And when was the last time? It was updated in September. Not too bad. And we're going to download the 64-bit version of that. I might just quickly, while we've got about another 10 minutes, just quickly download this and show you how that works. Open up in the Explorer, extract that, and extract the files. Super Slicer is not, you don't normally install it. Or at least the beta versions you didn't install. Let's see, is this got an installer now, or is it just going to run? Alright, so you don't need to install it, it just runs wherever it is. So we can just run it from the folder for now, because I'll move it around later on. And it's very simple. You're going to go in, the first thing it's going to do is to ask you which printer would you like to use, and we should see RatRigs, right, and we should be able to see a RatRig V-Core3.1 with a 0.4 nozzle. Okay, fine, I'm using a 0.6. We'll change that setting later. And next, no, we don't need any of these other printers for now. It's just gonna go through. Wait. Let's create, okay, custom printer we're not going to do. It's got its default set of plastics already there, specifically 3DO, B-Sun, some generics. Right, we can just use those as is for now. Next, the application wants to know if we can check for updates. Yes. I'm going to say next. We're not going to export the full partner for now. Next. We don't need to associate that because I'm not going to work with that much here. We're definitely going to go in the expert mode and done. Alright, so there's your slicer pre-built, and as simple as nozzle that we said was a nozzle setting was incorrect. We can edit the preset, and I can go and change that nozzle diameter to a 0.6 nozzle for now. Right, which means that it should be, well, shouldn't have to change any other settings further. Just hit save, modified, and I'm just going to say over here, instead of the word copy, I'm going to say 0.6. Okay. With that filament, I'm not going to print a ASA, I'll just do a PLA, and then you've got all your print settings. Now I'm not going to go through this. This is something that you need to have a look at in general on your own, as there are many different settings that you can choose here. This series of videos won't be about Super Slicer because I won't be using it much in the future, although it is well supported. I did use it. It is my backup slicer if I have a problem with Orca, but for now I'm going to stick to Orca. So I think you've got inside calibration. You can run a calibration cube, 20mm dimensional accuracy. We're not going to do a boron cube, we'll do a standard cube. Close. Look at the preview. It's a ridiculously small cube in the middle of nowhere. Yeah, maybe if we go to the settings over here, printer settings, we can go where, I'm not sure where it is now, I'm just going to think. Yeah, add a physical printer. V-Core 500, and say clipper printer, IP address 192.168.10. I think I made it 80. So let's remember test. Picked up the printer, say OK, and we could print. But the reason why I'm not going to print now is because I still need to, even if I slice, I can slice this now to do the slicing. It's ready to print it. Remember, I haven't been able to configure the bed mesh, so I first want to configure the bed mesh before I go forward. So I need to go and check those settings and come back to you with the next stream, and then we will print some blocks and something else. I'm not sure yet what we will print, but we'll definitely push some plastic on the next stream, and make sure that everything's working. By that time, I hopefully also have had figured out why this tubing that I've got is not working so well. Okay, so lots of progress. I'm very happy where we are, and thank you for everybody's support. I see even my father is trying to figure out who Pro V is. Really don't know. Pro V. Oh, Pro V could be. Oh, I think I might know who Pro V is. Sorry, I hit a blank now. That is my wife's brother. The other side. I didn't recognize the Pro V. Sorry, Peter Young. My apologies. But in any case, thank you very much for the support. If there's anything that you would like to know, please throw some comments and I'll happily answer those. Please make sure to hit the like button. If you're not subscribed, hit subscribe, and we will continue to do some, maybe 1 to 2 more parts on this printer build, and then we'll call it a day with the printer, and then we'll carry on with maybe some other videos. I've got some upgrades that I need to do over here. We might do some upgrades on that little printer at some stage. We will also look at upgrades on the lighting on this and the whole heating system and printing in ABS. Yeah, thank you very much, and have a good day. Cheers.